So the next thing we're going to talk about is box plots and outliers. So for a box plot, we're going to use our calculator and find the different parts of our box. So the left whisker is going to be our minimum. The first part of the box is going to be Q1. The middle of our box is going to be our median. The end of our box is going to be Q3. And our right whisker is going to be our max. Right. And so we're going to put this data into our calculator and try to find these 5 numbers in our calculator. So now we're going to go to Stat, Edit. If there's numbers in here, we go up, press Clear, go back down. And so we're going to 1, 3, just list all these numbers into L1. And then we're going to go to Stat, Calc, 1-bar stats. And we're going all the way down. So we're starting with minimum and we're doing these 5 numbers at the bottom. So our minimum is 1, that's where our left whisker is going to go. And then Q1 is 3, that's the first part of our box. Median is 5, that's the second part of our box. Q3 is 9, that's the third part of our box. And our maximum is 10. So we've got all these drawn. We're going to connect them and make a box in the middle out of those middle 3 numbers. And then we draw whiskers out to the side to connect them to the dots at the end. Right, so outliers have to do with box plots, and box plots are a really good way of seeing outliers. So outliers are numbers that are much smaller or much larger than the rest of the data. To find outliers, we're going to use these formulas. Q1 minus 1.5 times the IQR, and Q3 plus 1.5 times the IQR. So let's look at this box plot to help us with this one. We need our IQR, we need our Q1 and Q3. So our Q1 for a box plot is this first part of the line, and our Q3 is the last part of the box. All right, so for this one, if we're doing the first part, Q1 minus 1.5 times the IQR. So that means we're taking this middle set of data, we're multiplying it by 1.5, and seeing if we can go to the left that many times. And if we still have numbers outside of that, that's going to be an outlier. And then we do the same thing to the right. We take 1.5 times that Q3 and see if we still have numbers on the outside of it. And it looks like we probably will have an upper outlier, maybe not an a lower outlier on this one. So we're going to take Q1 is 4 minus 1.5 times our IQR. So in this case, our IQR is going to be Q3 minus Q1. So that's going to be 8 minus 4. So that gives us 4. And then we do the upper outlier. We take 8 minus 1.5 or plus 1.5 times our IQR, which is 4. So on this one, we get -2 as our lower boundary and 14 is our upper boundary. So that means anything below -2 or above 14 is going to be an outlier. And if we look at this box plot, there's nothing below -2. It stops at 0. But there is definitely outliers above 14. So we have at least one outlier above 14. With a box plot, we don't know how many points are above 14, but we know there is at least one because our maximum is at 17. So we would say yes, there is at least one upper outlier. Right, on our next one, we're going to do a dot plot. So the following dot plot shows the number of songs on each album in Sal's collection. Each dot represents a different album. Determine if there are any outliers. So for this one, in order to find Q1 and Q3, we're going to have to put this in our calculator and find our 1-bar stats. So we're going to go to Stat, Edit, go up, push clear, go back down. And for this one, we're going to put all of our numbers. So we see 4 occurs once, 7 occurs once, and then 8 occurs twice. We'll write it twice, and then just go through and keep entering our data. 10 occurs 4 times. Okay, so now we'll go to stat, over to calc, and one of our stats. We're going to go down and for Q1 and Q3. Those are the 2 that we're interested in right now. So our Q1 is 9, and our Q3 is going to be 13. So we take our formula Q1 minus 1.5 times the IQR, and then Q3 plus 1.5 times the IQR. So we're going to write out 9 minus 1.5 times 4, and 13 plus 1.5 times 4. So in this case, we get 3 and 19. So that means we can't have any numbers below 3 or above 19. Anything below 3 is an outlier. Anything above 19 is going to be an outlier. Has to be within those 2 numbers. So we look over here, our lowest number is 4, so that one is fine. But our highest number is 20. So we do have one outlier. In this case, it's different than a box plot. We can see each set of data or each data point. So we know this one is an outlier. So 20 is going to be considered an outlier. Yes, number 4 here. The list below shows the height in centimeters of 10 boys the same age. Determine if there are any outliers. So we're going to put this data set into our calculator to find our Q1 and Q3. The stat and edit. And we're going to put all of these numbers into L1. So we're going to clear out L1. So we have 97, 100. We're just going to keep putting all of these in. So now we're going to go to stat over calc and click on one of our stats. Okay, let's see there Q3 is 100 and our Q1 is 90. So our Q3 minus our Q1 is 100 and minus 90, which gives us 10. So our Q1 plus 1 times our IQR would be 90 minus 10, and your Q3 plus 1 times the IQR is 100 plus 1.5 times 10. So our lower fence is 75 and our upper fence is 115. So anybody lower than 75 would be an outlier. So we have one outlier, lower outlier. So 70 is going to be a lower outlier because it's below 75. And then we have some upper outliers as well, anything above 115. So 130 is going to be an upper outlier. So in order to not be an outlier, it would have to be in between these 2 numbers. Anything lower or higher, it becomes an outlier. So next we're going to